This is the first assignment for the first quiz in Algebra 2C. So you're going to be referring to these laws of exponents, especially adding and subtracting bases, and anything also to the 0 power is 1. So pretty basic laws there that you'll be referring to. And then this is new, laws of logarithms that I'll be referring to. So how you can simplify an addition of log statements into a single log, or subtraction of log statements into a single log. Also, while it's on my mind, you might want to, in the case of graphing, which is the next unit, know where your log base button is. So it's been a long time since I've used it. So you're going to go math and up arrow and log base right there. And so you'll see it like this. So whatever particular base, and we'll learn more about this, but it'll allow you to put any base in there. The other buttons, so this log here, the regular log, that's log base 10. And so whatever you'd be taking the log base 10 of. And then of course the natural log, oh, what's that in second function? Right there, that's log base E. And E is just a special value that has to do with things growing naturally. So know that in the right moment, we will be using the log base button. But for this assignment today, we're going to be referring to the laws of logarithms, especially these two. In this one, how to write one in terms of the other, and then laws of exponents, how to add exponents of like bases and how to subtract, and how to rewrite bases. So 6 problems each, and then you'll have your 6 problems to do. So what's different about these simplifications with exponentials? So an exponential is different than a power statement. So when you simplify power statements, so let's say if I asked you back in the good old Algebra 1 days to multiply x squared times x to the 7th power, or x to the 5th power, you would add those two, you'd keep the base, and you would add those two together. That's exactly what we're doing, except we're doing them with exponential expressions. And so this is important to know because this is a precursor to actually solving exponential equations correctly. And so the very first thing that you have to have are the same base. So notice that problems 1, 3, and 5 all have the same base. So I'm going to attack those first, and then I'll show you what to do if the problems have a different base. So if you have the same base, you're literally going to do what I just did. You're going to keep the base, and then you're going to add together whatever those exponents are. So x plus 5, and that's 2x plus 5. Done. Okay, for some, all right, I think I changed my answer. I had the wrong answer on the answer key. Wow, first problem of the new trimester. Not a good thing. But that is correct, 3 to the 2x plus 5. Number 3, if you have like bases and you're dividing, so if I said x to the 5th over x squared, you would subtract exponents. So that's exactly what we're going to do here. We're going to subtract these. And so what it amounts to is 7x plus 5 minus 2x. And that would be 4 to the 5x plus 5 power. Pretty easy stuff in the end. It's when you have to change the base that it gets a little bit crazy. So here, you need to probably add first, then subtract, or you can subtract, then add, it doesn't matter. So first step is you add the 7x and the 3x, 10x plus 5 over 2 to the 3x, and then you would subtract the 2. So you do not multiply together the bases ever. Okay, it's just the same base. So like up here, the x remain the same. You just apply the change to the exponents. So what happens if you're multiplying together and the bases are different? Well, what you try to do is you try to rewrite one of the bases in terms of the other. And so what I did here is I took the 9, and I can write the 9 as 3 squared. And so what good does that do us? Well, after I apply what's called the power to a power rule, and so let me find my trusty little exponent sheet here. So this guy right here is going to get applied a lot after you do the base change. So you're going to multiply together. So you see here x times y. So we're going to multiply the x, which we can call 2, and the y, which we can call x minus 2. Those are going to get multiplied together. And it's important that you distribute, that you do that multiplication together. So just look at this, 3 squared. So the 2 goes to the x minus 2. You just multiply by 2, whatever that new power is going to be when you rewrite it. Easy enough as you practice it. And now we have to add the 2 exponents together. So 3x minus 4. So top one, we have to rewrite with a power of 2. That's the easiest thing to do. And then again, we're going to distribute that 2 through that expression. So you're going to have 2 to the 14x plus 10 over 2 to the 3x. And then we're going to subtract our 2 again because we have the same base and we're dividing, so you subtract. So 11x plus 10 is that result. And then here we have to rewrite the 9 with a power of 3. So you just look at the larger one and you try to rewrite it as the smaller one. That's the rule. Pretty easy to do. So this is 3 squared to the 3x over 3 to the 3x. So that's going to be 6x. So you're going to add the 6x and the 7x. So 13x plus 5 over 3 to the 3x. And then you're going to subtract. So 3 to the 10x plus 5. So again, multiply here. Let me zoom in a little bit. 6x, then that 6x is going to get added to the 7x plus 5, making 13x plus 5, and then you're going to subtract, giving you 3 to the 10x plus 5 power for your final answer. Pretty easy stuff, but you need to know this because as you solve problems, you're going to have to simplify exponential statements. And that's going to be part of what you're expected to know. So when we get to solving logarithms, you're going to have to also be expected to simplify in your, addition, subtraction of logarithm expressions with the same base into a single base. So there's a couple of things you need to look out for. You need to look out for these rules here. So note that you multiply, when you add logs with the same base, you multiply their indices together. That's what's in the parentheses. And when you subtract logs with the same base, you divide their indices. Also, I think I have it on here. Oh, right here. So this guy here, should probably have this in a little bit bigger. So anywhere where we have a coefficient in front, we're going to move it inside the index as a power also. So I'll point that out as well when we get to it. So here we have logs of the same base, and we're going to add them together. And so we're going to put them together and multiply what's inside the parentheses. And of course, you should try to simplify that together. It's really important that you understand that the bases have to be the same. So 4x squared minus 8x. Now, the reason that we need logarithm functions and exponential functions is because for exponential functions, when the dependent set of data, the y values, if you want, is extremely large or extremely small, we need exponential functions to represent that data. for logarithms, it's when the inputs, the independent variable data, is extremely large or extremely small. So in my next video, I give several examples of what are good situations for exponential functions where the outputs are large or small versus situations where the inputs, the independent variable, is very large or very small. So you should look at that. It's also in this note packet. Actually, it's in the next one, the next unit's note packet. But we need these functions to deal with that data. All right, so we're adding again here on number 2. So that means we're going to multiply what's inside the parentheses. So we have x plus 2 times x minus 2. So that's a FOIL product, which you should be very good with now. All right, so you see this 2 here. So if you have any coefficients, they must go inside as a power on the index, whatever's in there. So that is this guy right here. So it's the other way. When you have this coefficient, it's got to go as the power in the simplifying process. And now you're adding again, so you're going to multiply together what you have inside and create one logarithm statement. So just be careful that you're doing that multiplying correctly and move any coefficients that you see inside as a power on that index number or function, whatever's in there. If you're subtracting, then you must divide. So this is log base 10. So when you don't have it written, it is log base 10. Okay, so note that your button on your calculator is base 10. It's important to always remember that. And of course, ln is log base e, which e is this natural number that has to do with how things grow naturally. So here we have to move this 2 inside. So you could write log base e if you wanted here. There's no reason that you can't do that. So you're subtracting, so that means you're going to divide what's inside out. And then our last one, we have the sum of 2 logs, which has got to be a product there. And then we must divide by this third one that we're subtracting. Okay, so when you multiply, you're going to get 3x squared minus 7x divided by 9. So it's important to be able to condense log statements that are added or subtracted that have the same base. If they had different bases, there's nothing you could do. But it's important to have this skill when we get to the next assignment, which is tomorrow, which involves solving logarithms. And that's where you see in exponentials, that's where you see these notes here, which I will refer to often in the videos. Okay, this is a pretty important set of notes here that you use it, especially when we get to the PERT formula. They made a formula after me. No, they didn't, but that's literally what they use to represent it. I'm not lying to you. Okay, so that's the first assignment for the first quiz of the 3rd trimester.